All right, so this is the second video in the graphing linear functions with the domain of all real numbers notes, okay? So in the first video, we graphed two basic linear functions where the number in front of x was an integer, okay? Here, the number in front of x in both these examples is going to be a fraction, okay? So if you'll notice, I've already changed the values I'm using for x, okay? In the previous example, I used -2, -1, 0, 1, and 2, okay? Here, because I'm multiplying a fraction times the variable, the math is going to be easier for me if I choose multiples of this denominator, okay? And I always want to try to use a couple negatives and a couple positives if I can, okay? So because the denominator is 2, I want to use -4, -2, 0, 2, and 4, okay? That's going to make sure my values that come out for y are all going to be integers and not fractions, okay? Fractions aren't bad, but if possible, we kind of want to stay away from fractions because it's a little bit easier, okay? So let's show the work here. Again, this is going to be linear because the largest exponent here is 1, okay? So our graph should form a line, and if you don't get a line once you've done all your work and you're plotting your points, it means you've made a mistake, okay? And you'll need to go back and check your work. So when we plug in -4, so 1/2 times -4 is -2. -2 minus 4 is -6, okay? So the x-coordinate -4 corresponds with a y-coordinate of -6. So we go left 4 and down 6, okay? Let's finish the table of values. Let's plug in -2. So half of -2 is -1. -1 minus 4 is -5, which gives me an ordered pair of -2, -5. All right, so again, notice because I'm using these multiples of 2, my y values are all integers. Makes it a little bit easier to graph. Okay, let's plug in 0. Half of 0 is 0, minus 4 is -4. Okay, so that gives me 0, -4. Let's plug in 2. Half of 2 is 1. 1 minus 4 is -3. And let's plug in 4. Half of 4 is 2. 2 minus 4 is -2. So that gives me a point of 4, -2. Okay, let's go draw that graph. Okay, so looking back at the table of values, we had our first point was at -4 and then -6. So left 4, down 1, 2, 3, 4, 5, 6. Okay, the next point was at -2, -5. Okay, the following point was at 0, -4. Then we were at 2, -3. Okay, you can see that linear form taking hold here. And then 4, -2. Okay. So the fact that these are all in a line tells me that my answers are probably right, okay? It'd be unlikely that I had 5 points line up and it'd be incorrect, okay? I would have had to have made 5 errors in my work. So we want to draw the graph, okay? So that's what the graph of y equals 1/2 x minus 4 looks like, okay? So let's move on to problem 4. All right, so the function in number 4 is y equals -3/4 x plus 1, okay? Again, I've used multiples of 4 as my x-coordinates here, okay, because my denominator is 4. That's going to allow my y values that I end up with to be integers instead of fractions, okay? So whenever possible, we want to eliminate fractions. It just makes the math easier. And the way to do that is we take this denominator and we use multiples of that for my x values, okay? So -8, -4, 0, 4, and 8 are the x values I've chosen to use, okay? So let's plug in -8. So -3/4 times -8. First off, it's going to be a positive. A couple ways we can do this. 3 times 8 is 24. 24 divided by 4 is 6. 6 plus 1 is 7, okay? So that's going to give me an ordered pair of -8, 7. Now, another way to do that, again, we understand a negative times a negative is positive. We could also think of it as this 4 and this 8 can be divided by 4, okay? So that's going to cancel out the 4. That's why I chose multiples of 4 for my x values. So when that 4 cancels out, this 8 becomes a 2, okay? We're simplifying basically 8 over 4 is 2, okay? So then that gives me 3 times 2, which is 6, and 6 plus 1 is 7, okay? So there's a couple ways to simplify this and get a positive 6, okay? You can always use a calculator too to verify your work, all right? Let's plug in -4, okay? Again, a negative times a negative is positive. These 4's cancel out. So this becomes positive 3. 3 plus 1 is 4. So negative 4, 4 would be the second ordered pair that I'd found. Again, if you want to, negative times negative is positive. 3 times 4 is 12. 12 divided by this 4 is 3. So 3 plus 1 would be 4 a different way. We always want to use 0 just because 0 makes it the math very easy. We don't even have to worry here. Anything times 0 is 0. 0 plus 1 is 1. So 0 comma 1. Okay, so whenever you have an opportunity to, use 0. That will make things easier for you down the road. Okay, let's plug in 4. Again, these 4's cancel out. So I'm left with negative 3 plus 1, which is negative 2. Okay, and then let's plug in the 8. Okay, if you want to think about it like this, 8 over 4 is 2. Negative 3 times that 2 is negative 6. Negative 6 plus 1 is negative 5. Okay, so 8, negative 5. Again, like before, if you want to, if it's easier for you, negative 3 times 8 is negative 24. Divided by this 4 is negative 6. And negative 6 plus 1 is negative 5. Okay, so a lot of fractions there. It's easier to use these values. If you use any values that aren't multiples of 4, you're going to end up with fractional y values. That leaves more room for mistakes. So I suggest using multiples of the denominator for your x values. Okay, so let's draw that graph now. Okay, so plotting those points that we just found for number 4, we had negative 8 and then up 7. So negative 8 up 7 is going to be right there. All right, negative 4 up 4 would be right about here. Okay, 0 comma 1 is here. Again, we call that the y-intercept. We're going to get into that more later on. 4, negative 2. Okay, again, you can see the linear pattern taking shape here. And then 8, negative 5, which is right there. Okay, so I've got my 5 points in a line. The domain here is all real numbers, so I have to connect those. Okay, so that's the graph of y equals negative 3/4 x plus 1. Okay.